Welcome to this video for the Insights Hub Quality Prediction video series, where we will give you a detailed overview of the application and equip you with all the needed information to get started with Insights Hub Quality Prediction. In this video, we will explain how to select the data for the quality prediction to start training models. Let's start the application from the Insights Hub Launchpad. After starting Insights Hub Quality Prediction, go to the Running Models. Let's take one of the models created for the battery coating thickness as an example and select the option Edit Draft. Once we created a draft, we can select the machine or asset which contains the source data. Select the asset and the corresponding aspect. After creating a certain description of the model, we can go to the next step to select the input parameters. Here it is important to select the time range for the training of the data. After selecting the time range, the corresponding data from the selected aspect will be displayed in the right tab. Here it is important to select the certain parameters in the model. For example, it's important to select the identifier, which is used to distinguish between the different produced parts which we want to use for the quality prediction, and it is also important to select the input features. These are the parameters of the process which will be used as an input for the model. Additional features based on time can be also selected for the model. For example, our production day, month, or duration of the process, or count of data point in the process, or count of interruptions. After the selection of this parameter, the corresponding data will be displayed. Here in the right panel, we are focusing on two types of processes. The cyclic process, where you see the selected cycle for each part, or also the continuous process, where we only have one data point per part or per measurement point. In both cases, it's important to select the identifier to describe the particular part. In this particular case, we use the part number and we use the coating bar, gap, coating ratio, and coating temperature as inputs, and select some additional features based on the production time. Now, after the selection of these parameters, we go to the next step where we select the filters. Filters are necessary to remove non-productive data and to only keep data points which belong to a particular process phase. In this case, we use the program status as a filter and only select the data points with a certain program status which are considered to be productive. Remaining values for the program status will be considered as non-productive and will be removed out of the evaluation data. In addition to that, we can apply outlier filters to remove outliers out of the selected dataset. After completing this step, we continue with the aggregation, depending on the type of the process. For the cyclic process, we use the aggregation if we need to group multiple data points which belong to one part. In this case, you have to select the aggregation. Here we can select the aggregation parameters, for example, focusing on mean, value, and standard deviation. You can also select the minimum and maximum values. For the transients, we can remove the very first and the very last data point of the production phase, because we can face a certain delay with the transmission of the data to Insights Hub. These data points can represent some artificial outliers. After completing this step, we will start by selecting the historical quality data as target values to train the model. We expect to have quality data in Insights Hub in the integrated data lake as a file. With this step, we need to select the corresponding file and check if we have all the necessary attributes and variables to reflect the quality variables. In this case, it's important to have measurement results, tolerance limits, and identifier. For example, the part number is used in this case as identifier to link the quality data and the manufacturing data selected above. Next, we will go to the wizard and map the corresponding variables. Here we need to select the timestamp and the variable which is responsible for the identifier, tolerances, and the target feature to be predicted. With each step within the wizard, we visualize the data at the right tab. At this step, we selected the process and quality data with all required pre-processing settings. The preparation of the data and the data check is now completed, and the data is ready to train and evaluate the model. We will explain these functionalities in the next video.